This is the second half of the lecture for Chapter 3, accompanying CIS 307. Chapter 3, the Relational Model 2 Sequel. This is Nancy Dugan, your instructor, and we are starting with example 12 for the second half, which begins on pages 86 and 87. We did the first lecture half went through the basic SQL commands using the MySQL program, and now we'll get into some of the more advanced basic commands. They're still pretty basic, but beginning with some computed fields. So what we want to do now is list the number, name, and available credit for all customers. So the SQL statement is going to basically select the customer number, customer name, but notice this calculated field here where you're saying the credit limit minus the balance, and then you've named that field as available credit. So this as statement is just saying that, hey, when you figure out what the credit limit minus the balance is, give it a heading at the top of the page that tells me what or that names it available credit at the top of the column. So when we come over here into our SQL, we're going to go ahead and I've already have everything for example 12. I'm going to go ahead and execute that SQL, and I'm going to get 10 rows down here. Notice that the column heading here is available credit. So it's put that name on it because of that as statement. The next example that they give us of a computed or calculated field is example 13. They want us to list the number, name, and available credit for all customers with credit limits that exceed their balances. Okay, so this starts off basically the same. I've got my calculated field right here, credit limit minus balance. I've named that field available credit. I've also, in my criteria down here in my where clause, I'm saying that I only want to see those where the credit limit is greater than the balance. So if we take a look at the MySQL, I'll go ahead and select those lines. I'm getting 8 rows returned. So I'm selecting the customer number, name, limit, minus balance as available credit. I've put that part of it all on one row. Let me zoom this in. And then from, and then the where clause. How you string or where you decide to separate your rows is up to you, but usually you'll do it in a fashion similar to mine for ease of reading it back to later. Your textbook then goes into some special characters or special operators like and in. And I can't imagine a day going by where I wouldn't use these two. These two special characters, special operators are tremendous. They're used commonly, constantly. So in example 14, they want us to list the number, name, and complete address of every customer located on a street that contains the letters Oxford. So maybe the street name is Oxford Junction, or maybe the street name is Blue Oxford. I don't know. I just want to see the ones that the street name contains the word Oxford. So in MySQL, I'm using the %sign in a fashion that is similar to what many other programs use the star. The star is a wildcard character representing 0 to an infinite number of characters. And typically you'll see the question mark in a lot of programs that represents one single character. In MySQL, we use the %sign to represent the 0 to infinite number of characters, and we use the underscore to represent a single character. By that I mean if you had T_M, that would bring back Tim, it would bring back Tom, but it would not bring back Trim, because there would be more than one character between the T and the M. It would only bring back with an underscore where there was specifically one character. The %sign, on the other hand, could be any number of characters. So I'm saying this might start with the word Oxford, it might end with the word Oxford, or it might have the word Oxford anywhere in the middle of that street address. Here's the actual SQL code, and when I execute it, I end up with just one record in this example, Johnson's Department Store, but notice that street address is 372 Oxford. Their next example is using the special operator of in. So I'm saying list the number, name, street, and credit limit for every customer with a credit limit of $7,500, $10,000, or $15,000. So here's my select statement, and look at my where clause. Credit limit, the name of the field, in, and then I've listed the three possibilities. Now, notice that I have no dollar signs, I have no commas. That's just formatting. When we may choose to display a dollar sign, we may choose to display commas, but we don't actually use them in our criteria statements. Here's the query itself in MySQL. When I execute it, I get 8 rows returned. Now, if you didn't use the in character, let's take this a step farther. If you didn't use in, what's the other option if I didn't know about the in? Well, the other option would be where the credit limit equals $7,500 or credit limit equal $10,000 or credit limit equal $15,000. If you notice when I execute that with the or and the or, it's going to give me the exact same data set. It's a lot less typing to use the in. I want to take this a step farther, and I want to also show you that, and while they do mention this at some point in your text, because it's on your test, I want to put the word not in front of that in. And when I do that, take this same query and execute it, notice what I get, the two records where the credit limit equals $5,000. By putting the word not in there, I'm reversing the criteria. Without the word not, I'm saying the credit limit had to be $7,500 or $10,000 or $15,000. When I put the word not in front of the word in, I'm saying the credit limit cannot be $7,500 and it cannot be $10,000 and it cannot be $15,000. So it's important that you realize that with the in, you also have a not in. Similarly, you would have a not like. If I came back up to this one and executed it, notice that I'm getting every address that there is, but not the address that contains Oxford. That's one address that I am not seeing in my resulting data set because I put the word not in front of the word like. So remember that you can always use the word not to reverse that criteria. Example 16 introduces the sorting capabilities within SQL. We want to list the number, name, street, and credit limit of all customers. Order or sort the customer by name. Now, you might think that the command you want to use is sort by, but notice that in SQL it's order by. So the select statement starts off just the same. All of your fields from customer, but you add the line order by customer name. This is number 16, all the way down here. When I execute it, I've got my order by customer name, and if you notice, they're in alphabetical order by customer name. Now, if I did something as simple as come to the end of that and add DESC for descending, I'm going to select that again. Notice now they're in reverse alphabetical order by customer name. So now I'm going from Z to A, where before I was going from A to Z. This is simply because I added the descending. Your author has an example of this in example number 17. But they've actually done two things together. They're telling you to list the number, name, street, and credit limit of all customers, order the customers by name within descending credit limit. In other words, sort the customers by credit limit in descending order, and then where the credit limit is the same, sort them in ascending order by name. So look what we've done here with our order by. We're saying first we want to order it by credit limit, and then forget the descending for a minute, because if I just wanted to order it by credit limit and then by customer name, I'd have credit limit, comma, forget this, and then I have customer name. That'd be put them from 0 to 10,000 or whatever the highest is, and if the credit limit's the same, sort them in alphabetical order by customer name. But that's not what I have. I have this DESC. So I'm saying order by credit limit in descending order. So that means it's going to give me the largest one first and bring it down to the smallest one. And then where the credit limit is the same, it's going to go in customer name order, ascending. Why do I know? Because there's nothing back here telling me descending. You don't tell it ascending. It will automatically be A to Z or 1 to a million. Only if you put a descending in there will it reverse that sort order. So take a look at how this works. Example 17, execute. Now, my order by says credit limit descending order. So if I look at the credit limits, I've got from 15,000 in descending order all the way down to 5,000. And then customer name doesn't say descending order. So within here's three records that are $10,000. And notice that it gives me bargains, then Brookings, then Johnson's. Here's all of my $7,500 ones. Looks like there's 4 of those. AADF. And then my $5,000 ones, LT. So it's sorting them in descending order by credit limit, and then when the credit limit is the same, in ascending order by customer name. Example 18 begins to use the SQL functions for some of the built-in functions. These are things like count, average, max, min, sum. When we take a look at the first example, all they want to know is how many parts are in item class HW. So select count star means count the records from part, the name of the table, where the class equals HW. It's a very simple query using that count function. It's going to return a single value of 3. It's counting all of the parts where the class equals HW. Very simple built-in function. Example 19, find the customers and the total of their balances. So select count, that's going to give me the number of customers, sum their balance from customer. Pretty simple query, pretty straightforward. It's going to return one record because I'm saying count all of them, total all of them, or sum all of them from this table. I get 10 for my count. I get 47,651.75 for my total. Count and sum functions are some of your easiest functions. They talk on page 94 about the average, max, and min, that they're similar to sum. Max, of course, returns the highest value, min returns the lowest value, and average is the one that they demonstrate. You're responsible, of course, to know all 3. I believe your homework will have some max and min in it. I know your test does. So select count star, so all of the records, and I could put a field name in here. If I put a field name in there instead, like if I said count address, and I had 10 records with an address and 1 without, it would return 10, not 11. Where if I did count star in the parentheses, even though I may be missing a field of data on any particular record, as long as the record is there, it's going to count that record. Now, before, when I counted, if I looked at my last example even, notice that the column heading was count star and the column heading in the balance was sum balance. So really what I'm doing now is there's my count star, but I'm actually naming it customer count. And there's my sum balance, and I'm actually naming it balance total. I thought they wanted us to do an average, but I guess not. They're just adding names onto our query to give it more meaningful names. So this example 20 is really identical to example 19, except I've added this as customer count and as balance total. The end result of that is it's giving me better column headings. That's all that's doing for me. It's giving me better column headings. Page 95 has example 21 and introduces subqueries. With subqueries, it's like you're querying a query. You have to first create a query and get a set of data, and then you're going to query that set of data. So if you did them one at a time, what you did first would be the subquery. When you do them together, you list the larger one, and then in your where clause, you're going to put the query that gets you that subset of data that you're actually querying for the. It's like a parent-child relationship. I don't know what other software you might have used, but it's explained differently in different programs. So we're going to select the order number from the order line where the part number is what? Well, there's that subquery. So you can think of it as, first I have to do this. First I'm selecting the part number from part where the warehouse equals 3. That's giving me a subset of data. This is a subset of data. Once I have that subset of data, it's that data that I'm going to use to select the order number from the order line where the part number is in that subset of data. So let's go ahead and take a look at how this works. Notice when I put it in how it puts this minus sign here. This allows me to expand or collapse the subset. If I had numerous subqueries, I may want to hide some of them in order to work with other parts, and MySQL has that functionality. When I actually execute the query, it's giving me the result set of the 3 order numbers. I should have said earlier too, and you've probably seen by now, I've put some comments in here tonight just to help me with this many queries, one after the other. I wanted to have some numbering over here in my SQL code to help me find it faster. Notice that I started the comment line or the remark line with a pound sign. Notice when it's not selected here how it's gray. That's just allows me to put comments into my SQL code so that I can keep track of where I'm at or why I did something, maybe what parameters I have to put into a certain piece of it. Maybe, like here I may want to put a note in real life that says, make sure you change the warehouse number as appropriate or something. I would put all that in something starting it with a pound sign. That way it's not actually part of the executed part of the code. Notice when I select it though, it doesn't matter if I select it with the comment or if I select it without the comment. Either way, it's going to ignore the comment. I'm going to get the same result set of data. So I wanted to make sure I mentioned that. I've put a couple of other things in here in the next one that your author doesn't do. In example 22, the author introduces grouping. And so for each sales rep, list the rep number, the number of customers assigned to the rep, and the average balance of the rep's customers. Group the records by rep number and order the records by rep number. Now what the author does is, or what I added is this. So I'm going to go ahead and cross this out for a moment because I added this. Just cross that out. So we've got select the rep number, count all the records, and figure out the average of the balances. So it just be comma and then AVG parenthesis balance parenthesis. From customer, group it by rep name, order by rep name. Now if I do that, let me go ahead and change this so it matches the author. If I do that, when I execute the query, notice what I get for my average balance. Notice how I get the 0.6666667 and the 0.93750, etc. Well, I want it to be formatted differently. Now remember that a format does not, in any program, does not change what is actually stored. A format changes how it looks. So if I had, let's go to a program as simple as Microsoft Excel. So I'm over here in Excel, and so many people just don't understand what formatting does and the difference between formatting and rounding. I'm going to put in a 1.3 and a 1.3, and I'm going to simply total those two together. I get 2.6. Makes sense. I'm going to simply format that for no decimals. And suddenly 1 plus 1 equals 3. Well, if you think about it, 1.3 rounds to 1. 2.6 rounds to 3. So it might kind of make sense to you. But reality is I have 1.3 and 1.3 added together. And now I'm saying 1 plus 1 is 3. And that's because all I've really done is change what's formatted. A format changes what you see. It does not change the actual value that's there. That's what rounding does. And all I really want to bring up today is formatting. So what I added to the author's code is I put the word format with an opening parenthesis in front of average. And then I put a comma 2 and a closing parenthesis at the end of the author's balance average balance function. So the author in your textbook has this. We're on page example 22, so page 96 and 97. So the author has this. For their screen captures, they're using Access program. We want to, MySQL has more flexibility. We want to learn the actual SQL program. So some of the syntax is going to be a little different as you're discovering. So the author has the average balance. I've added here the format parenthesis and then afterwards the comma 2 parenthesis. Let's go ahead and see what the difference is. Remember how we had all of these decimal places before? Now with that formatting in there, notice how it's changed it. So I have 0.67, 0.94, and 0.67. I am only seeing 2 characters. Why 2? Because I have a 2 over here at the end of my format. That's why I'm only seeing 2 characters. Now, I emphasized that there's a difference between format and rounding. Formatting changes what you see. Rounding changes what's actually there. If I change this from the word format to the word round, I select it again, it looks the same. But now it's actually going to, if I used this number now in a future calculation, it's going to treat it as 0.67. If I use the format function, that number is actually 0.666666666666 at some point 7. And that would carry forward in all my future calculations. So there's a time and a place for each one. Sometimes I want the format and sometimes I want the round. At this point in this chapter, your author does not talk about either one of these, but it's important that you know these functions as well. So what I'm adding to this is the format parenthesis and the comma 2 parenthesis. Example 23 is on pages 97 and 98. For each sales rep with fewer than 4 customers, list the rep number, the number of customers assigned, and the average balance. Rename the count of customers and the average of the balances to num customers and average balance respectively, and order the groups by rep number. So we're trying to take a lot of the different concepts that you've learned so far and put them together into this one example. So coming back, here's still the result set from my last example. Notice the column heading names. When in example 22 I had count parenthesis star parenthesis, I didn't put an as after it, so it named the column count star. In my format here, I think the last one I did was round, the last one I executed or format it had earlier, the column heading is again that whole calculation. Look at example 23. I'm still selecting the rep num just like I did in 22, the count star, but I've added as num customers. So I'm giving this column a name. I still have my balance, average balance. I've got the formatting on it as I explained earlier, but I'm naming this by adding as average balance, I'm naming the column name. From customer, exactly identical. Group by rep number, exactly the same. Order by rep number, down here, exactly the same. But I'm adding this line, having count less than 4. So I only want to see this data for those where the count is less than 4. I'm going to go ahead and select this and execute it. Now, I only get 2 records because I have 2 with 3 customers, 2 records, 3 customers each. Notice the column headings. where before this was count star in the earlier example 22. Now that I've added the as num customers, my column heading is num customers. I added the words as average balance, so my column heading is average balance. So the big differences between 22 and 23 are I'm adding these as statements in order to give the column a better name. I'm adding the having in order to put criteria on there. When in the same way that a where might have a select would have a where, a group by has a having. So I might say select star from customer where customer num equal 73, whatever it is. So I'm going to have a where. But the minute I put a group by in there, I need to use the word having instead of the word where. 24, example 24 is on pages 99 to 100. Here I'm introducing the concept of joining tables. So in other words, I want to now get data when one piece of data is in one table, another piece of data is in a different table. I want these two tables to be, somehow I have to tell it what fields the relationship is between these two tables is, or how these two tables are related to each other. So I'm going to list the number, the name of each customer together with the number, last name, and first name of the sales rep. So I've got the customer table and I've got the sales rep table, and I somehow need to tell it how these are related to each other. So okay, I've got all my fields. That's pretty easy. So this is what the big select is the names of all of the fields. And here's the name of both tables separated by a comma. Then in my where clause, I have to tell it how these two tables are related to each other. The rep name from customer equals the rep name from rep. Notice how I had to separate the name of the table from the name of the field with a period. I had to do that in both sides so that it knew. Now, technically, this, of course, rep number is the primary key of the rep table and the foreign key in a customer table. A primary / foreign key, the fields that a relationship is built on, technically these two fields do not have to have the same name. They have to represent the same thing. So in other words, it is fully possible that in one of the tables I would have named it rep num, and in the other table I would have named it representative number. Two different field names. It has to represent the same thing. Now, experience will tell you that it's easier to always refer to that field as the same thing, even if that means that when you actually write the query, you have to specify the name of the table with a period and the name of the field name. It's still better off, overall, you're better off to have it be named the same thing. Notice, however, not only do I have to, in my where clause, separate the name of the field from the name of the table and spell it out this way, but up here in my select, since rep number appears in both tables, I have to actually include the table name separated by a period or a dot and the field name in the select statement as well. If I don't do that, I'm going to get an error message that says it doesn't, basically is saying it doesn't know which rep number to pull. It doesn't know which table which table that field should come from. Therefore, we're not going to give you a darn thing. So let's go take a look at this in SQL. This is example 24. Okay. So here, again, notice here how I have the rep.rep number here to specify the name of the table and the name of the field, and I've got it again in my where clause, just as I was saying. And when I execute, it's going to return. Looks like it's going to return 9 records, maybe. Hang on, I'd have to pull this up again. 10 records that with some of the data coming out of the customer table. These two fields are coming out of the customer table, and these 3 fields down here are coming out of the rep table. It knows how that data is related to each other because of this where clause creating the actual relationship. I feel like I'm rambling now, so let's move on to example 25. Pages 100 to 101, we're going to list the number, name of each customer whose credit limit is $10,000. We also want the number, last name, and first name of the sales rep who represents the customer. So we basically have the exact same thing as last time. The exact same 5 fields, only now we're putting some where criteria on it. So I start off with the fields. Notice again, just as before, for this one, I have to put the table name and the period. Notice here on my first part of my where clause, I'm specifying the table name and the field names for each side equal to each other, separated by the period separating the table name from the field name. Notice I've had to include an and in order to have my actual criteria in the where clause. So if we take a look at this in SQL, right, here's my example. When I execute, I'm getting 3 records, a resulting data set of 3 records. So in this example, I have the relationship, the joining tables on the rep number between the customer and the rep, as well as criteria. Credit limit has to equal 10,000. The third and final example of joining tables is example number 26. In order to do this example, you need to do some prep. When you get into your Henry Books and your Alexa Mara group for your homework assignments that you have this week and next week, you also need to do this same prep to any date fields that you have. What I need you to do is open the Premier code that was provided and find the rows that insert into the orders table. So here's my Premier code, and when I go through that code, I'm going to come all the way down, and for me it's rows 87 on down to about 107. And I need to find those rows that insert, I believe it's 7 records, 7 records into the orders table. Your records won't look like this because your date will say October 20th, 2013. October being spelled out in an abbreviated format, OCT. You need to change the dates provided to the format of year-month-day. Make sure you use the correct dates. So I've got 2020, 21, and 23. So I had to come in here, select what was there, and manually type this in. And then I'm going to take from this first insert into orders all the way down through the last bit of data. So for me, that's rows 87 to 107 if you don't have any other commands in here, and execute it in order to create the orders. The table was created. It had no data in it because the MySQL that we're using did not understand the date format that the author provided. If you want to verify this, when you're done, simply do a select star from orders and execute. You should see order dates in here now. If you still see no data, you need to again examine those particular lines in your Premier code and figure out how to alter it so that it will accept those dates. Once I've done that, now I can actually work with example 26. For every order, list the order number, order date, customer number, and customer name. In addition, for each order line within the order, list the part number, description, number ordered, and quoted price. Order the records by order number. So this query is actually pulling data from 1, 2, 3, 4 tables. So notice my from has all 4 tables listed in it separated by commas. This query has multiple fields that appear in more than one table. So notice in my select statement how I have to have orders.order_num. Later I have customer.customer_num. Later I have part.part_num. If I don't remember to put the table name and the field name, I'll get errors because it does not know which table to pull that particular field from. Look at the 3 where clauses just to create the relationships between those tables. I'm saying that the customer number in the customer table is equal to the customer number in the orders table. And the order number in the orders table is equal to the order number in the order line table. And the part number in the order line table is equal to the part number in the part table. I need all 3 of these lines in my where clause in order to create the relationships between the tables. If this was a much larger database and I still had other criteria like, and the credit limit has to be greater than 10,000 and the customer number has to be, or the customer state has to be Iowa, whatever I want, I would need more ands and ands and ands, because remember, my where clause is going to both create my joins as well as give me specific criteria for the subset of the data. Finally, I've put a sort on it by saying order by orders.order number. Again, because the order number field appears in more than one table, I had to specify the table name even though it's in my order by. When I execute this, I'm going to get a large set of data. This may not seem amazing at first, but this is truly, through the relationships and through the joins, is really where the power of relational databases comes from. I just pulled the order number and the order date from the orders table. The customer number and the customer name. The customer number is in the orders table, but I pulled the customer name from the customers table. The order line, so I have one invoice and they might order 10 widgets and 14 wobbles. So those order lines are the specific order line items on the particular invoice, which is in orders table. So when I see here this order 21610, that is in the orders table once, but it's in the order line table twice. And it's in the order line table that it tells me that they ordered one DR93 and one DW11. But it doesn't bother to store the description because the description is stored in the parts table. And the quoted price is stored, I believe, in the order line table. So that's 4 different tables that I'm joining together in order to execute that entire query. Example 27 introduces the union function and begins on page 102. A union of 2 tables is a table containing all rows from the first table and the second table, or in other words, rows from both tables. In this case, I want to list the number and name of all customers who are represented by sales rep 35, or that currently have orders on file, or both. Okay, so these 2, everybody who's represented by 35, everybody who has orders on file, 2 completely different ways to get to that. So here's my, here's my everybody who has representative 35. That's shown to me here. And then over here in the next set, I have everybody. Sorry about the noise. There we go. I have everybody who is same fields, only everybody here my criteria is just everybody in the customer table who has an order. So if these, they have to, I'm going to have customers who I don't currently have orders on. Maybe they're potential customers. Okay, so this is giving me one set of data. This is giving me another set of data. And this union command here in the middle is joining these 2 subsets of data together. This is example number 27. And when we execute, we should get something similar to this. Example 28 starts to introduce our action queries. The first action query we're going to do is an update query. Now, when you do these next 3 queries, 28, 29, and 30, you're going to be modifying the data in your actual tables. Remember that in future examples, be it homework or chapter examples, etc., to always look to see if you should proceed with the data set from the prior chapter, in other words, what you may have altered in the prior chapter, or more commonly, go back to the original data set itself. So, and when we start chapter 4, I'll actually go over how the first time we need to go back to the original data set. I'll make sure I include that in the lecture so you can see how you actually make that happen. Okay, so now we're going to actually do an update query. An update query means we're actually going to change the records in the table so that the data that was there is gone and this new data takes its place. We want to change the street address of customer 524 to 1445 Rivered. So this is update. Customer is the table. Set the street to equal to, and there's my address in single quotes, where the customer number equals, and there's my customer number 524 in single quotes. I'm not sure if I said this before or not, but you need the single quotes whenever it is text or character data, character string. A number like customer number is not stored as a number, it's stored as a character string because we will never do calculations on it. So when we set up the table, it was stored as character or text fields. Something like a price would be stored as number, so then it would not need quotation marks around it. All right, well, I think that I do have one example, yes, of that coming up in 29. All right, meanwhile, example 28. Update the customer, and we're going to set that straight. Let's take a look first, just so you can understand how this happens. Let's start off and let's go select star, from customer. Let's just take a look at the data right now. Here's 524 Kleins, and notice that the address is 838 Ridgeland. I'm going to now take this update query, and I'm going to go ahead and execute it. Okay, seems like nothing happened. Actually, if I pull this up, which I hid earlier, I can see down here that I have one row affected. It does tell me all of that, so I know that something did happen. I'm going to come back to my select star from customer. Remember, it was Kleins. 524 Kleins. Notice the address now in the table has changed to 1445 Rivard. So I have actually changed the data in the table. That's what an update query does. Example 29 is an insert command. We're going to add a new sales rep to the rep table. Her number is 16. Her name is Sharon Rands. Her address is 826 Raymond, Altonville, Florida. Zip code. She has not yet earned any commission, but her commission rate is 5%. Of course, in order to do this, I would need to know the actual fields of the table and the order of those fields. Insert into rep, the name of my table, values, and notice all my values one after the other separated by commas in parentheses. Notice that those values that are text or character are in single quotes, like her rep number 16, her last name Rands, her first name Sharon, etc. But those values that are stored as numbers, like her how much commission she's currently earned and her commission rate here at the end, are not stored in are not included in single quotes because they are not text. Again, if you wanted to verify that this is working, I could come up here and do a select star from rep. We have, if you had a huge amount of data, you'd want to put some criteria on this, but we have such a small amount of data, this is okay. So I'm selecting everything from rep. I see 3 records, rep number 20, 35, and 16. Now I'm going to go ahead and run my example 29 query. Again, you don't see anything because it's not a select query, it's an action query. It did something. What did it do? Well, I'm going to go ahead and come back to my select star from rep, and notice now I have a 4th rep. Her number is 16, her last name's Rands, Sharon, etc. Example 30 is an example of a delete query. I want to delete any row in the order line table in which the part number is BV06. Notice the syntax. I'm starting with the word delete from the name of the table. Where, and there's my criteria. Again, if you wanted to verify this before you begin, let's go ahead and do a select star from order line. This is going to allow me to see what is in the order line table right now. And I think I did an 8 instead of a star. There we go. All right. So I currently have records in here. There's my BV06. See it right here? And it says 2 have been ordered, 794.95. There it is. Now, what was my actual delete query? I want to delete anything where that part number is there. So I'm going to go ahead and select the code for example 30, execute. Again, you'll feel like nothing happened. If you look down here in your output actions, I'm going to take a second and look at that. Okay, we were operating in safe mode, which would not allow us to execute a delete query. So in order to change this, I'm back at my SQL workbench, and I need to go ahead and edit my preferences. And my workbench preferences is going to open up, and the 4th tab over is SQL queries, and right now you have this safe updates checked. You need to go ahead and make sure it is unchecked so that You are not forbidding updates and deletes with no key in the where clause or no limit clause. This does require reconnection, so I had to close that script window and come back to my main window in order to change this in the workbench preferences. I'm going to go ahead and click OK, and then I'm going to go ahead and connect to my database, which opens the SQL editor back up. I'm going to go ahead and open my script file. I'm going to come back down to the code I had for example 30. Actually, just so we can see where we're at, I'm going to go ahead and go back to my select star from order line. Whoops, forgot to choose a database. And select star from order line, and here I can see then the order number 21617 with the BV06 in it. I'm going to go ahead and select my example 30, which is going to delete it. I should see down in my output one row affected, but just to verify it, I'm going to go ahead and select star from order line again, and that 21617 with BV06, that order had 2 lines, the one that's BV06 should be removed or deleted. So that's how that's something that I need to do in my version of Workbench before I can execute that delete query. So you'll want to make sure that you go back and do that to your own version. Again, when you're in the main window, it was edit preferences, and then it was the I can come over and look at it, but you'll have to reconnect it. SQL queries, and it's the second checkbox. You want to make sure it's unchecked. You will have to reconnect to the database after you uncheck that box. And then finally, example 31, which is on pages 105 to 106, and kind of brings it full circle because we started off having to discuss how to create tables, table creation, way up in example 1. We created a table, and now we are here in example 31, creating a table. The difference here is that we're going to create a table based on the output we get from another table. So in other words, I'm going to, or another query. I'm going to create a query, and whatever I get in my output, I want to take that data and use it to create a table. So the new table is going to be named Table Small Cust, for small customer, consisting of everything from the customer table when the credit limit is less than or equal to 7,500. So I've got another one of these query subquery relationships going on. Here's my create table with all of my fields defined, just like we did in example 1. And then I'm going to insert it into, or that creates the table. Insert into that table. And what am I going to insert? Select star from customer where the credit limit is less than or equal to 7,500. So if you think about it, in reality here, I should be able to take just these select star from customer to see what I get. I've selected these last 3 rows so I can see the resulting 6 data records. Notice over here in my tables, I do not have a table called small cust. Now I'm going to go ahead and select all of the code for example 31 and execute. Okay, and again, give me a moment. It's telling me that doesn't like my code for the create table. Okay, when I look at my code, I realize I have a stray opening parenthesis. I'm going to go ahead and remove that, and then execute my code. Yes, to break this down and find my mistake, as I said, I had a stray parenthesis here in front of credit limit. I removed that, and I'm just going to select the create table functions and execute. It comes out just fine that the table was created. You see the green check here. If I refresh my tables over here on the left, I can see the table I created for small customer. Now I'm going to go ahead and examine my insert into. I must have a oh nope, it did that by itself fine. It's Whether it would have worked if I'd had them all selected or not, I'm not sure. Once I separated them into two commands, it was fine. So here's my my four insert into commands. I executed those. It seems to have put 6 rows into my table just fine. And now to verify, I'm going to select star from table small cust and execute, and you can see that I have taken everything from the customer table where the credit limit was less than or equal to $7,500, taken that subset of data and put it into a table which I created called small customer. Now that concludes the last example in chapter 3. If we take this a little bit farther, just so you know, on pages 107 on in your chapter, it gives you a summary of the SQL commands. You're always going to be looking at the top one. Sometimes it's the same, sometimes it's not. For example, on page 107, example 1, the top is the MySQL code. Then it tells you, well, if you did this in Access, it would be a little bit different. So it shows you how to do it in Access, basically because of the numeric field types in that one. But examples 2 and 3, you'll notice there's no separate set of commands for Access. There's going to be another separate set of commands when we get all the way up to example 14, a different way to do it between the MySQL and the Access. You're going to have that again when you get up to example 31, this last one, where it's got, if it's in Oracle or MySQL, it's a little bit different there. So you'll want to, that summary doesn't give you any of the words, but it just gives you the example and the code, what they were looking for, list the XYZ from this or that table with this criteria in the blue box, and then the code without any of the explanation. Good luck as you move forward, and that concludes our basic SQL chapter.